Okay, thank you very much for inviting me. So my name is Dalziel, and I'm an architect and now also a material supplier and consultant. And this presentation is in a way the story about how that happened and what I'm doing now with all of the partners that I'm working with both in Norway and across Europe, where many of these materials are coming from. So Matera, the name Matera is this combination of materials and architecture. It also happens to be the name of one of the oldest cities in the world, which is a combination of architectural facades and caves. So Matera in Italy. So it's also the name for a container. So for me, it was a very beautiful name to use for this, because really what I'm doing in this practice, what we're doing in this practice, is gathering important things together in a container and learning about them. So Matera is a kind of tool for holding all of these ideas. And first and foremost, at the moment in 2025, what the practice is doing is acting as a material supplier. We're also architects, but at the moment, both because the architecture business is a bit quiet at the moment, but also because I'm very much focused on building this capacity in Norway. The focus has been collaborating with other architects, other interior designers, and also private customers and the building industry to make the literacy and availability of these materials increase. So I'll talk a little bit about all of these materials through the projects that we've been doing, but the projects that we've been doing are now many. And the story of Matera starts really in 10, even 15 years ago, with when I started to play around with bio-based materials, living in London as an architecture student and then as an architect, and then continues through to today. So I will talk through these projects and through each of the materials as we go. But the first thing to say is that, I mean, of course, the kind of discourse of sustainability is highly complex. And one of the things that I've been doing to sort of focus the way that the practice works and how we work with others is to try to have some kind of key principles. And one key principle, of course, is that this is a design-led practice. So we are as interested in the beauty of these materials as we are in the carbon footprint of these materials or their capacity to perform as energy efficient partners in a system. And so I think that's really important, is to remember also that sustainability can be beautiful, and the practice of making a kind of regenerative architecture can be an engaging, creative practice. And so one principle from the technical side that we really focus on, which helps us to get there, is to say that we're very focused on natural ventilation. That I personally think that this diagram that sort of comes first from space research and then becomes the passive house standard, which has resulted in many new buildings, most new buildings being made as a plastic bag, which is regulated by a machine, is a very strange way to treat our species. We should have a physical relationship with the materials around us, and making it that the first material we touch is really like a plastic lining which isolates us from the world is kind of philosophically and technically weird. So the approach that we take is making sure that the wall is vapor open and that the materials have a capacity to breathe and to hold moisture and hold heat. And that tells us a lot about the kind of materials that we can use. So in maybe a simple way, you can say there's two kinds of ways of building. One is vapor closed and one is vapor open. And we are very much the vapor open focus. And so when you start to look at how to build a wall as a vapor open system, you have all of these layers. And sometimes a single material can operate as all of these layers. And that's a kind of architect's wet dream in a way, to make a solid stone wall that can be thermally massive and insulating and materially rich all in one layer. But often, and especially in kind of competition or comparison with the way that we build as a standard form at the moment, what it means is looking at a lot of different layers and how they react. And one thing that's very interesting, and I think a big selling point for biogenic materials like these, is that the way that we build at the moment with these kind of technical layers and airtightness and plastic means there's a high degree of risk of failure. If tapes fail or membranes fail, then the rest of the layers fail. Whereas when you start to build with natural stone and caulk and cork and clay and wood fibers and hemp fibers and all of these materials that are on the table here, all of these materials have a capacity to dry out. And so they can stay there for 1,000 years. If the roof is on, they will stay there. So there's a kind of way in which not only are these materials already inherently low carbon because they're made of mostly of harvested plants and some minerals, of course, but it means that there's a kind of inherent longevity in the materials. But just to say a little bit of where I come from. So I speak with a bit of a kind of, they say, a mid-Atlantic accent because I was born in Canada and I grew up in the UK. I studied architecture in the UK, and afterwards I worked for really 2 practices over the course of 10 years before coming here. The first was Howard Tompkins, who are very well known for their cultural buildings and particularly for transforming and extending historic theater buildings. And I think that's really where I learned a lot about the capacity for materials to tell stories and to draw histories forward and to talk about the future and to be these kind of tactile agents, almost like performers in the space. And that's been really formative for me. The other element, which then kind of naturally evolves into what I'm doing now, is that I worked for 5 years at Web Yates Engineers, running with a partner a small architecture team within that studio. And Web Yates, some of you will probably know, have been for a long time very active in promoting the use of natural stone as a structural material. They have this project called the New Stone Age. And in fact, now they're building a 12-story residential building with structural stone. And this was the first one, which is Clarkmore Close. They built with group work on Taha Architects, really quite brutally expressing the structural stone. So I think it's that particular project, but a lot of what they do within the practice is a great example of how approaching sustainability from a creative praxis perspective and method is super exciting. To sort of turn it on its head and say, hang on a second, actually taking this thing out of the ground and smashing it up, firing it at 1400 degrees Celsius and putting it back together with a bunch of steel to make a less strong, higher carbon, higher energy material in a lot of applications is quite weird. So structural stone becomes super interesting in that discourse. And it's a kind of a different perspective on extraction. That extraction can be a bit like, when we extract, we use the whole animal. Like when we kill the pig, we feed the pig and then we eat the pig. So I see like natural stone is a kind of responsible way of using these more precious materials within the palette. During that 10 years, while I was working in those 2 practices, I was restoring a ruin that I was also living in at the same time. And this was my kind of hands-on tuition on bio-based materials, which came kind of, I was sort of forced upon me because I managed to buy this bit of historic London, which had been utterly destroyed by modern materials. So this is a kind of a bit of the plan on the right-hand side where the dining room and living room are, is the servants' quarters of a larger Victorian house. And then the rest of the plan is an extension which kind of tries to express a sort of bay window, playful nod to the bay windows that happen on the rest of the street. But what had happened was that the house itself had been injected with chemical damp-proof courses and plastered with cement and lots of plasterboard and glass fiber insulation, and it had become virtually uninhabitable because it was so damp and cold and filled with fungus. And the only thing to do was to take all of that away. And so this is a 50 square meter, started as a 50 square meter house, and we took, I think, 70 cubic meters of waste out of this building by scraping away layers. Literally filled the yard where the extension came later with rubble, and then experimented with using lime, with using hemp, with using sheep's wool, developing relationships with local forests where we get oak and larch from English forests, and did all of the work myself on weekends over those 10 years, and really got to know what's happening? Is there one slide? Oh, maybe I inserted a slide and then didn't put anything on it. The next thing that happened is that little architecture studio inside Web Yates Engineers won the bid to curate the Oslo Architecture Triennale. So my wife, who was also part of that, Cecilia Sachs-Olsen, and I ended up coming to Oslo quite often and eventually decided to move here. But the theme of the Triennale, which was kind of moving from thinking creatively about sustainability to thinking about economics and politics as part of that challenge, led us to propose this idea of looking at the degrowth movement, and the question asking about the relationship between architecture and capitalism, and really asking about this idea of what is the architecture of sufficiency? How can an architectural practice and indeed a built environment industry work with an idea of efficiency, sufficiency, and enough? And you see a lot. I mean, of course, we're not the only ones who are working in that area and have continued to work in that area, but it's very exciting to see that the move towards restoration and transformation and the discussion of circularity and regenerative practice is very much following this kind of method of saying, like, what we have as much as kind of speculation and creation of the new. And as part of that project, I was the main exhibition designer for a piece that we transformed the Architecture Museum into a library of degrowth, and that project tried to take the method or the message as the method, so we basically redigested a Snøhette exhibition using all of the materials that were already in the space from the previous exhibition to build our new piece. And then outside with students from a studio I was running at the time at Aarhus, built this installation, which is a 14 cubic meter compost pile that heats a public bench through the bioreaction of the compost. And through making that project, I started to think about what I could do with 14 cubic meters of compost. And later, the project, which is the house and garden that I'll talk about, came to be. But just quickly, because this slide was there, this is another kind of seed for what became the house project that I will talk about, House for a Forest. And one element of thinking about biogenic materials that is an interesting provocation is to say the easiest way to eliminate concrete from a building, or really contact. And it's kind of interesting to think about how the architectural baggage that we've inherited from the kind of neoclassical tradition of having these heavy bases isn't essential. It's just, in fact, an architectural style. So, of course, not in every project we always are going to need to have a relationship with the ground perhaps in urban environments, but there are many projects where having a much lighter relationship to the ground is possible, and you see that now with screw pile technology. And I was seeing the other day that the kind of biogenic society in Denmark has produced these technical guides, and the one relating to foundations is very much focused on screw piles. So this was a small project, a sauna in Lillemarka, where we were really looking at a kind of delicate and playful way of having a relationship with the ground. And then another project which came in the next Triennale, answering the question of mission neighborhood in that Triennale, asking this question about more than human neighborhoods. So when we think about making good neighborhoods and good cities, we almost always immediately are thinking in the human perspective. And so this installation was talking about the tradition of food forestry and agroforestry, which are really also in parallel to regenerative construction and architecture. Agroforestry is kind of revolutionizing, or at least troubling, we can say, industrial agriculture, and you see a lot of moves towards that kind of companion cropping where forest methods are being used. So this was an installation where a living forest is placed inside a hemp and clay kind of sculpture where you can put your face in the hole, and you're then transformed down, like Alice in the Looking Glass, to a scale where you can imagine being in this food forest. And those two projects, the kind of lightness on the ground and this idea of the food forestry project, then became the house which I built for my family, which was also is also, because I haven't quite finished it, the main case in a works-based PhD that I've done at Aarhus. So this project is a kind of performance art piece where I because I was the builder and the architect and the developer, it was an opportunity for me to really push the limits of everything that Matera is trying to do. And so the first step to that was making a biodiversity hotspot, saying, I will arrive to this tomt in Uppsala in the same way that Howard Tompkins would arrive to a listed building. Everything there is precious, and everything there can be elevated by a new contribution to the space. And so the first thing that we did with this project was, instead of building that house first, which would normally mean scraping away the topsoil and cutting down the trees and terraforming the landscape and all that, we planted more than 100 species of edible plants and started a kind of community compost project. We took down all the fences and invited the neighbors to make soil with us on this site. And you can see now this is the This was taken last summer, so it's the 4th year of the food forest, and it was very exciting this summer. For the first time, it really has an interiority. It's the forest has kind of, in certain pockets, really become dense. And this is the house that then arrives on the site. And this house is also a kind of an attempt at a radical performance of all these things. So as much as humanly possible, no concrete and no plastic, which always in the end means some concrete and some plastic. And as much as humanly possible, zero waste, which of course also always means biogenic materials that come in plastic bags. But all of the offcuts from the construction were composted on the site, and all of the materials from the system are as local as possible and as biogenic as possible. So the main structure of the house is made from Norwegian massive tre. And I know there's a whole kind of carbon discussion about boreal forest and forestry practices and embodied carbon. And so there's this question about, like, could we have gotten CLT from Austria that was actually lower carbon than the CLT from Norway? And that might be true, but it's not a kind of reality that I want to engage with. I would like to believe that the trees from 1 hour away are the right trees to use. And if we need to change the forestry practices to make that true, then that's the project. So the gran comes from Norway. The oak comes from Norway. The house is, of course, some of you will be familiar, is the first hempcrete house in Norway. And part of that was because of an interest in the story of hemp in Norway, that hemp is, in Norway is the last country in the Western world where it's illegal to grow hemp. There are 3 countries in the European continent and Nordic region where it's illegal to grow hemp, and it's Vatican City, Monaco, and Norway. And it's the oldest cultivated plant in Norway. We think it was an essential crop for farmers for 200 years. And so I've been speaking a lot and working a little bit with Norges Vel, trying to drop the ban on hemp and develop that discourse. And the hemp for this house, in fact, came from France. But in the meantime, the first refinery for hemp shiv and hemp fiber in the Nordics opened in southern Sweden. So now we get our hemp fiber from Evolution, southern Sweden. So it's coming closer all the time. And this is how the house is built, which is that the CLT elements are basically the internal walls and the floor and roof structure. So it's a kind of house of cards with no structure on the outside, all prefabricated. And then the outer walls are a 6 centimeter wood fiber plate with this just lightweight stud work, 50 by 100 studs that are basically there to hold the wood fiber in place. And that we did that because the process of casting hempcrete, which is a blend of hemp and lime, when you do it as an in situ system, needs formwork. And so by having that wood fiber plate on the outside, we not only protect the building from the elements and allow the drying time of the hemp to extend into the shoulder season of the autumn, which is essential in Norway. We get a little spike on the U value by having that 6 centimeters of wood fiber on the outside, and it's permanent formwork, so it decreases by half the waste that is used, which is something we reuse the formworks, but so we maybe used 6 plates of OSB for the whole house that we just moved around. So the inner plate is a sacrificial form, and the outer plate is a permanent formwork. And the critical thing here that I want to talk about is, so we geared the thickness of this wall so that it absolutely just passed. We did a total energy calculation and made sure that we were only just in the green in the Simeon calculation, because what we wanted to know was that all of the gains in energy efficiency that we had were gains because of material, not gains because of extra performance, if that makes sense. And the thing that I will show as I go through the rest of the projects in the presentation is these 2 factors, which is the U value and the storage capacity, which is the capacity for the thermal mass of the wall structure to act hygroscopically. For these calculations, I'm just using Ubocus, which is a very kind of basic but sufficient calculator for performance. There are more sophisticated calculations that can be done in Woofy and Woofy Pro, and we've done those for this house, and the house is in fact performing better in Woofy than it is in these, so we can say it's 0.18. But the heat storage capacity is an important element of that first principle that I talked about, where fresh air is coming into this house, and is the energy that is used to heat that air is held in the walls. So when you open the windows to get extra air, if you need to, if you have 30 people over and the CO2 goes up, you could open the windows for 10 minutes and you close them, and the temperature is essentially the same in the house, because the delay that comes from having the mass is a kind of performance that the house is capable of. So the palette of the house, this is actually the acoustic wall between the apartment and the house, because it's a kind of double house. We used clay plates and wood fiber and hempcrete and wood fiber on the floor and CLT. And then on top of the hempcrete, there's 15 millimeters of clay plaster, a base plaster, and then a fine finish plaster, which comes in lots of lovely colors. And this project was then the beginning of developing these trade relationships, which we now have with where we're the kind of ambassador for all of these products in Norway. And then I want to talk a little bit about. Go on.
Yeah. Just before, was that floor? One more, please. Mm-hmm. Was that floor heating?
Yeah. So there's water pipes. Yeah. So this house could be completely naturally ventilated. We took the approach that because we needed heat anyway, that it made sense to use a waste heat air pump. So it's an air to water heat pump. So we just have, I think one kind of key principle for me in terms of looking at sustainability is that architecture should be slow and technology is fast. And that means that the technology should be hot swappable, and that buildings that are designed to last for 500 years should not be too tightly tangled with anything that's going to become obsolete. So this building has one machine, which is plugged into one duct. And we can swap out that machine. And we can also, the thing that's interesting about an air to water heat pump is that it has two coils in it. One coil that's connected to the heat exchanger, and the other coil you can connect to whatever you want. So we've been thinking about, can we connect that to the compost pile? Can we connect that to passive solar heating on the roof? Can we connect that to, so there's also possibilities for upgrading where that hot water comes from, but the hot water is the heat source and the domestic hot water in the house. And that makes a very comfortable environment where, the bedrooms are downstairs and the living spaces are upstairs. So the bedrooms can be a lot cooler. All the fresh air comes in on the lower level. And then the upstairs becomes this kind of warm cocoon where the hot air is rising and then captured right at the top of the house in a kind of typical naturally ventilated diagram where you have kind of a vertical section where the air is coming in and making its way up. Thank you for interrupting. Please do that. So then I just want to talk about this guy a little bit, because, of course, that project, which was a kind of performance art piece where we were able to make something that on a cost per square meter basis was more expensive than normal people could afford, because I literally built it myself. So there wasn't any labor cost, and it was sort of partly funded by a PhD and all this kind of stuff. So it was a kind of off the system experiment. Coming out of that, we really need to know about this, which is the standard wall that is built in Norway, 600 kroners per meter squared. And it's then we look at the heat storage capacity, 16 kilojoules. So this is a kind of super optimized wall section, which is optimized for two things: to meet regulations in terms of kind of isolated energy performance and cost. Mm-hmm. And for me, the only thing that I can compare this to in the world is a McDonald's hamburger. So this is something which is optimized absolutely for cost and doesn't produce a healthy world that I want to live in. And that's the challenge, is that the first wall system that I will show you that we're working with now is 2 times the price of this. And so the thing is, we have to say, we can't just compare those on square meter costs. We have to say all of the reasons why that 2x price is both a fair and a good price, because it's doing all of these other things. So the first step to trying to answer the challenge of a wall section, which is built as a vapor open wall structure with this capacity for heat storage, is to really reduce the amount of hempcrete in the wall. This could be another material. It can be more clay, for example. And this is the second project that we've done, actually the third project that we've done with hempcrete in Norway, which is now almost finished on site. And so what we're doing here is we're increasing the amount of wood fiber and decreasing the hempcrete layer, or the thermal mass layer, to effectively that service zone layer that's in the glass fiber or mineral fiber wall section. So you have this service zone layer, which is your fire layer, your airtightness layer, and your thermal mass layer. And you can see it still has 105 kilojoules, which is more than enough. As I understand it, anything above sort of 50 kilojoules is giving you a good amount of thermal mass for the performance. And this project is interesting because it's, you guys, I guess, can see those materials. We've been able in this project to use a lot of the materials that we're working with. So lime cork insulation, hempcrete blocks, formaldehyde-free OSB, wood fiber plates, clay plaster, and also these 3-layer kind of micro CLT plates that we use a lot for furniture in the projects. And then we've been lucky enough to get some money from the Klima Fund from Oslo Klimatotten, and are working with NMBU to do real-life testing on these 2 projects. So we're putting sensors in the walls, and we'll do a kind of 2-year project where we're measuring what the moisture is doing and what the real-life U value of the houses is. We already know from living in the greenhouse, House for a Forest, for almost 2 years that we use about. Now we have someone living in the apartment, so it's gone up a little bit. It was like 30 kilowatt hours per square meter, and now it's about 40 kilowatt hours per square meter. But it's something like 60 to 70% better than Texan. And that's more or less what the literature said about what hempcrete should be doing. And that's because of its kind of hygroscopic dynamic effects, that it's absorbing and releasing moisture and absorbing and releasing heat, and effectively working as this kind of passive machine to help the real machine, the active machine, to not have to work so hard. Then moving on from new build to restoration, one of the first projects Matera did at the beginning of 2025 was with one of the interior designers from Mad Architecture for a house her and her partner bought, and they discovered that it was actually a log house. There was no evidence of that from the way the interior had been fitted out over the years, but we scraped it all the way back to the logs and found also that the logs had rotted out in a lot of places. Windows had been moved, and particularly because the ground floor is brick and the upper floor is logs, the lower 3 courses of logs had just rotted away, and someone had put some props in there. So hempcrete became a really interesting way of patching that solid core of the building. And then we used reeds as a kind of isolation layer from the movement of the logs, and clay plaster on top. So you can see the build up there of first the repair layer, and then the reeds, and then the base clay, and then the final clay. And the other thing we're doing, this is coming with hopefully with some funding in the next stage of the project, is introducing this cork lime plaster to the outside of the system. We have a sample of it here, and I'll show some more in some later slides. Yeah, that's right. So this is basically a lime plaster which is blended with cork aggregate, and it has a U value on the bag. It says 0.037. They now have actually got a 0.035 measure for it. So it's a highly insulating, vapor open. It's the same principle as hempcrete in that it's a bio-based fiber, or in this case, a kind of bio-based aggregate, which is storing a lot of carbon from a regenerative forest practice, because cork is a bark that's harvested every 10 years. And then the lime is the binder that protects that fiber or that biogenic aggregate from degrading. So actually the lime, although the lime has, of course, a carbon release in its life story, is also a protection to make sure that that building can stay for 500 years and hold that carbon. And also the lime is reabsorbing through the carbonization process. So the longer the building stands, the more carbon positive the material becomes. The place this material is super interesting, I think, for us in the Nordic region is in restoration and transformation, because we can add a thin layer of this to an old log building or an old masonry building and really get air tightness and a boost in thermal performance. And also when it's applied on the interface of buildings, you get a surface which is warm to the touch. So the surface temperature comfort is very high. So in this case, what we will be doing is taking the wooden cladding off the logs, spraying the whole building with 3 to 5 centimeters of this, and then putting the cladding back on again. So it also becomes this invisible layer where we can boost. As you can see, the U value is going from 0.7 to 0.34.
You mean you're spraying this one?
You spray that on, yeah, exactly. And so this is a demonstration the product is made by a company called Dalziel in Italy, and we took some architects there late last year, and this is them proudly demonstrating spraying 16 centimeters in one go of this. So it can be sprayed very, very thick. And one of the things, although this material is, of course, more expensive than lekting ut with glass fiber, the speed and the kind of single activity make it almost cost neutral, especially in thinner layers.
When you say glass fiber, you mean like Glava, for instance?
I was avoiding using a brand.
Yeah. Just to clarify.
Yeah. Glass fiber mineral wool.
When you say lime, is it lime? Okay, thank you.
Yeah.
I was a bit confused.
Mhm.
Yeah.
So this is another case study from last year where we worked with one of the partners from Skapa and his wife on their house where they have a concrete basement where they've made 2 apartments. And we basically did a study where we said, okay, you were going to lekt ut with mineral wool or glass fiber insulation and plasterboard in the standard way. And we know what the cost of that is per square meter. I think it was something like 300 kronor a square meter, materials only. And then we can look at what the cost of this is, which is something more like 800 kronor a square meter, but we can spray 500 square meters in a day. And it is the insulation and the finish, but it's also protecting that concrete wall and the inhabitants of these apartments from moisture and salts and creating a healthy situation for both the building fabric and the occupants. So what we found is that the speed of it brought it down to, I think they would say that it was still a little bit more expensive, but then you have all of these extra benefits. So that's really the game that we really have to play as ambassadors to these other ways of building, is to talk about the other value factors that come into play when you invest in these materials. And of course, the price of these materials will also come down with availability. This is another project, the second in situ cast temporary project we did with the local architect in Hamar. And this is a good example of how we work with other architects and other entrepreneurs. So on this project, we just supplied the material, consulted on the detailing, and then I went and trained the mester on how to do hempcrete, but I was just on site for a day, and then they just went with it. So I think this is a really interesting way of working, which is how we like to work at Matera, which is being hands-on with these materials to the extent that we can train people on how to use them. So it becomes this kind of infectious practice where we can make them available, we can show you how to use them, and then you can go and run with it and do your own projects. And this is actually our showroom in Compton, where we're hopefully going to do this test with the cork plaster on the inside and outside of the masonry structure. So you can see the improvement is vast, 1.26 to 0.32, by putting 3 centimeters on the outside and 5 centimeters on the inside of the solid brick wall. And that's possible even while maintaining all of the ornament on the facade, of course, because we can take all of the concrete plaster off. And on this building, it's basically falling off anyway, and reapply a new plaster with the same thickness, but that has a U value of 0.035. That is breathable, that is warm to the touch on the inside, and that, I can't remember what the EPD on that is, but it's pretty close to carbon neutral because of the combination of lime and cork. So it's and other materials you can see in these pictures, we're using clay plaster. This is an example of how you can use clay plaster directly on old finishes. So this is just like the wallpaper that was there. We put a mineral primer directly on the wallpaper if it's stable, and then this Josima clay plaster, which is a 2 to 3 millimeter thick layer of plaster directly on the old surfaces. And going back to that diagram I showed at the beginning with the layers, every layer matters. So even if you just use clay, I think a lot of people think they can't switch to vapor open systems because they already have a fabric which is made of all of these vapor closed systems. By putting that skin of even just clay paint, 1 millimeter of paint, you have this porous surface area, which is doing something. Of course, 10 millimeters, 15 millimeters of clay is going to do much more. The first 1 to 3 millimeters is really doing much more about moisture than it is about thermal buffering, but it's still worth doing. The ceiling is interesting. It's original lime ceiling with reed mats that we found and restored, and then used clay paint because also with clay paint, then you don't lose any of the detail of the ornament. This is a project which was with Lusetter. So this is the bakehouse at Lusetter, which had been made as an art project and got permanent status last year. So it needed some restoration. The wattle and daub clay plaster that had originally been made with was actually falling off and quite dangerous. So we got funding from Sparbank to run a course where we restored this building by taking all of the, in fact, not all of it, you can see a little bit of the back of the clay plaster there, where it was intact on the inside face. We left it and used it as formwork for the hempcrete, but we filled between all of the ribs with hempcrete. And this is, we hope, the first phase of several phases to extend the useful season of this building and participate. Biogenic materials have a very close relationship to the sort of urban gardening movement. So it's very nice for us to be there in that community. And finally, then this is a project we completed for an exhibition which is on now in Lies Holland at the National Museum, where we used our wood fiber plates and clay plaster to make these large walls for the Anawana exhibition that's there at the moment. And the clay plates then are interesting because they're the wood fiber plates, unlike the clay plates, they're very flexible, so it was easy to make these curved surfaces. And I think this is another use case where we can say, by using clay and wood fiber instead of plasterboard and plastic paint in exhibitions which have a very short turnover, we can really decrease the amount of waste that's coming out of the cultural sector. So I'm very interested in continuing to work with the National Museum and others to change the specification of the materials they're using as maintenance materials and as exhibition materials. So we have another project with the National Museum happening now, which is very exciting. And that's the exhibition. So I will just end there and say thank you very much.